So first up, we have Ram. Ram is a PhD student in the Faculty of Information at the University of Toronto. He's a graduate fellow at the Data Science Institute and a graduate affiliate of the Schwartz-Raymond Institute for Technology and Society at the University of Toronto. He is interested in understanding the various tensions, expectations, and subtle technical assumptions involved in developing machine learning-based information systems and developing tools to support machine learning practitioners and other stakeholders in their fairness-related work in practice. So his research is interdisciplinary and covers topics in fate, machine learning, social networks, and human-computer interactions. So Ram, take it away.
Thanks for having me here. Thanks, Yo and Sierra, for inviting me. So this, yeah, so so this talk that I'm going to give is based on a recent paper that we published at a conference called CHI, on understanding how machine learning practitioners use different techniques in practice. This work lies at the intersection of responsible AI, as people typically call it now, and HCI, human-computer interaction, and is based on, as I said, user study with practitioners with technical duties. By technical duties, I mean like data scientists, engineers, and so on. So what I'm essentially going to do is I'm going to share some experiences, challenges, and aspirations of these practitioners to give a glimpse of what is happening in this field on the ground. So a data scientist we spoke to for the study shared that the responsible ML, or ML for short, mostly do not happen in a structured way, and it's only coincidental that these things work. This is expected to some extent, like given how a variety of strategies, like from model cards, data shades, if you're familiar with that, like there's so many different way of documenting stuff, so many different way of making sure machine learning models are following ethical values. Mostly these happen in informal or unstructured ways. The later literature has called this field as a hodgepodge, like mixture of so many things. Nobody knows what's happening, using different strategies that they like and pursuing in different ways that they want, and so on. So there's some literature that I've seen what practitioners do and what they need, but they happen mostly in isolation. What was unclear was that if is there a methodology for responsible ML? So that's the question that we sought after for the study. We discuss the various constraints that determines a practitioner's methodological approach to responsible ML and what are the characteristics for it and so on. So I will discuss like three insights, three main characteristics of the methodology for this talk. The first one is, the first one is abstracting ethical inquiries from their day-to-day activities. So we found that practitioners abstracted the responsible ML workflow from the inquiry of the applicability of machine learning to a specific problem. So this is not to say that like one should ask whether machine learning should be applied or not, or whether machine learning should not be applied, and so on. But the goal was in the process of investigating why machine learning is a good approach. Several assumptions and choices made in practitioners' routine steps like may get exposed, and that may have several fairness or ethical implications. And here's a statement highlighted in red from a data ML scientist in healthcare. They said that consider the pre-processing fairness techniques we use, such as relabeling, reweighting. These are different strategies to use machine learning fairly. We assume that labels of some data points about human demographic and clinical details can be relabeled without actually knowing if that is okay. We mostly do it for statistical convenience. So what we could take away from this is that many micro decisions of technical practitioners, in their routine steps, such as like operationalizing different theoretical constructs, like imputing missing values, as simple as that, or like transforming certain features, like these are all related to fairness of ML systems. They have several fairness consequences, but implicitly or explicitly, practitioners tend to dissociate these inquiries from their day-to-day activities. And oops. Here are some more examples. Like, oops. Oh, yeah. Here are some more examples. So, a lead ML scientist said that even if your model is unfair, if it's doing better than baselines for all cohorts, it still might be worth deploying. So maybe your recall scores, it's a metric to measure how good a model is. On women or worse, significantly worse than the recall for men. But the baseline there is so bad that you should still deploy the model because you still do good for those cohorts. So there are many ethical questions here, right? Like what is good for the cohort? Who decides what is good? And why do you think the baseline is bad? And just because the model performs well on a particular metric, is it okay to implement them and so on? But those things are abstracted out. And here's the second quote is somewhat similar, where a data scientist in human resource development said that we always think in terms of good, bad, and ugly. Like it's about reducing your area of concern in such a way that you're able to deliver value, even if it's 30 or 40%, referring to their system performance. It's good if it's still better than the current process. So that's the idea that the practitioners tend to have in many domains. We discuss in a paper how such perspectives are naive interpretations of complex ethical dilemmas. So, in essence, practitioners abstract out these responsible ML inquiries or queries and do not juxtapose their everyday assumptions and choices with fairness considerations. They apply machine learning by making different assumptions, they get the system out, and then pursue fairness or ethical inquiries later. The question that we grappled up here is how to nudge these technical practitioners to invoke critical reflections on their daily activities and responsibly apply ML at every phase of an ML lifecycle. Like that's something that we are currently trying to do, and I'll come back to that towards the end of the talk. Um, so and then so the second assumption, the second characteristic that I want to discuss is how the complexity that's underneath applying machine learning is simplified in different ways. So in computer science and engineering and maybe some other domains as well, there's this tendency to break down complex problems into simpler problems so that we can solve them, like effectively and efficiently. But when the same logic is applied for fairness or ethical inquiries, it creates more issues than solving the original problem, right? Um, for instance, there are different toolkits, so-called toolkits or frameworks that are used in this field to help practitioners apply machine learning fairly or ethically. And when practitioners follow these toolkits, they refer to a range of support systems, like from data sheets or model cards. They often aspire for an ideal state. So by ideal state, I mean uh, a state like, for instance, like answering all questions in the data sheets or responding to different like queries in model cards and so on. Like for instance, open sourcing model parameters, ChatGPT related models, they open source different parameters, right? So just following these tick marks or check marks is seen as like deploying machine learning responsibly. But like responding to these questions often creates a picture that machine learning is responsibly applied, but it's not definitely the case if you see in practice. So consider this quote from a data scientist, a machine learning scientist. They say that we have to sometimes break some of the assumptions of SHAP. SHAP is a explainability tool, as in to understand how AI model functions underneath. So it's used to explain AI's decisions. So they said that, for instance, they referring to like different stakeholders and managers and so on. They would expect us to run SHAP with say 40 or 50 data points. And yeah, so when the assumptions don't hold and the features that SHAP deemed to be important also have to be taken with a good grain of salt. So here, SHAP is a technique used to, like show which features are important for a machine learning system. But practitioners, like there are so many constraints determining their day-to-day activities. Like they have this resource and business constraints coming to their daily life, and it's influencing how they apply different techniques for responsible ML. So again, they consider another example here. Like sometimes developers violate a value and then satisfy it later. So knowing why and how some point in the guidelines change is very important than just versioning. So sometimes the values held by top level stakeholders, like companies management change, and some values become inappropriate, such as like robustness or like some other specific values. But how these values mutated was typically not recorded or not discussed in the documentation process. These toolkits may be developed with a good intention, like intention of invoking deliberate discussions, like making sure the machine learning is responsibly applied and so on. But what we found in practice is that the design of these technologies encourages the application of ML as per some specific guidelines. It's often used to justify the application of ML, but not to reveal and invoke discussion on underlying complexities of applying machine learning to a social problem. So, so far, what I've discussed is practitioners abstract out fairness inquiries from the day-to-day activities, and then they aspire towards an ideal state through toolkits. However, such idealization often lead back to abstraction again, resulting in simplifying of underlying complexities. The third characteristic that I want to discuss is how like I discussed in the beginning, that most of the responsible ML practices, including how different values are understood and interpreted among human stakeholders, they do not happen in a structured way, and many participants aligned with the view that it is largely coincidental that these things work. So we so there's a like people in computer science and later fields are talking about aligning missions to human values, but there's a tension among aligning humans, like there's a tension in aligning humans among themselves, like different humans, different people coming from different disciplines background are still figuring out how to align how they interpret machine learning systems. And our paper argues like how we should focus more towards that before starting to thinking about aligning, or simultaneously while thinking about aligning machines to human values. So this is a quote from from an academician working on ML for education. They said, like, we had a team who was presenting an algorithm they developed to predict student success in order to provide appropriate advice. But one of the academic advisors are domain experts here who do not have any knowledge of machine learning systems, not formally trained. They just ran out. She was angry. She smashed the door and walked out. And she said, like, no, I'm not doing this. This is totally ridiculous. And it was not because the system was not well designed or because the AI was not sound. It was because it was trying to advise something that she didn't feel was appropriate advice to a student. So the takeaway here is, like, many values and their implementations were understood in different ways by different stakeholders, but they were largely unclear on how to address the disconnect between values and interventions and their implementations systematically using existing tools and frameworks. So existing tools tend to, like they're designed with an intention to support, but what's missing is like how to address a disconnect between different interpretation. And here's yes, I want to discuss one particular disconnect, which is how technical practitioners communicate their technical duties and assumptions choices with stakeholders of non-technical backgrounds. Like, say, data scientists, how do they interact with like a business manager or someone from AI safety team and so on. Like, so here's a question. Here's a code that demonstrates that well. Like, a senior data scientist said that communication with non-technical audience is very important. I should not use deep learning jargon and not even use terms like distributional shifts, etc. In one instance, when I tried to discuss why I processed the data like this using SHAP, again, an explainability toolkit that we saw before, they were not interested in such conversations. I insisted that I assume something about the data which might impact how our model predicts for some input data points. However, they said all these were okay as long as the model performed well and the shaft produced good plots. So it all reduced to that, like so many abstraction idealizations reduced their duties to like generating good plots and good metrics. So one specific questions that we are trying to figure out now is like, how to design tools and frameworks that facilitate collaboration and discussion of technical choices and assumptions. Like what goes into the development of models, like with stakeholders of non-technical backgrounds. This is an ongoing work. So here's a like complex. It looks like a maze now from seeing on a big screen. So what it is, inspired by all these findings, we proposed a framework, a theoretical framework to methodologically apply machine learning responsibly. So this is a framework in the sense it's a template of how machine learning practitioners, technical practitioners, can apply, like machine learning to a social problem. We discussed we propose like 5 layers, like undesirable properties, realized goals that can be realized in practice, and what they stand for, like what abstract values they're trying to realize, and what are the interventions that are taken to address different undesirable properties, and what are the known assumptions behind these. So consider this feature dependency here, like on the left, right? Feature dependency as a undesirable property. Now this is mapped to so again this is a map to explicitly show that there are different problems, and we are doing different interventions, and these problems affect different goals. So this is a theoretical framework to show explicitly what's happening on the ground. I can't go in detail how they are populated and so on, but at a high level, I'm going to pick an example here. So if you consider feature dependencies as a undesirable properties, it's mapped to the realized goal, robust to high cardinal categorical data. So what you need to understand here is that feature dependency is a problem. Like when features in a model are dependent with each other, it creates several issues for the model's prediction. It creates less robust views. This implies that achieving the goal of building robust models is hindered by high cardinal features, and explicitly showing this mapping of how interventions address different undesirable properties tend to help practitioners to discuss more, discuss their assumptions with different stakeholders in a more effective way compared to what they're doing now. So we discussed how such a map can invite participation from diverse stakeholders, of different backgrounds, and invoke critical reflection on technical practitioners' daily activities, and help them apply machine learning responsibly at every phase, not only towards the end, but at every phase, from data collection to data annotation to, um, uh, you know, like uh, like updating the model through feedback loop. And note note that such visualizations can also help identify and keep track of unaddressed desirable properties. So in this case, the ones with the question marks, they're unaddressed. Like usually when people do not explicitly map what they're doing, they tend to ignore these things as the model goes on. Like all these unaddressed things tend to be clustered under a section called limitations and future work in many like accountability documents that these models are supplied with. But what we proposed is that we proposed a method to like make these connections explicit. Okay, I'm done. So last just 1 minute. So the summary is implementing AI ethics in practice is challenging. We discussed that there is a need to systematize value alignment discussions among different humans from different backgrounds. We require tools and framework to facilitate collaboration between technical and non-technical stakeholders in AI. And currently, we are trying to we're trying to develop new accountability toolkit for technical practitioners, and we're trying to co-design a new documentation framework. Again, we're coming from HCI and machine learning background, so it's an interdisciplinary work. And if there are any AI practitioners here in this crowd, please reach out to us. We'd like to talk to you. Thank you.